All right, so yesterday we left off at the conical pendulum, and today I have some good news. Well, I already announced it. We are going to finish circular motion, but we're going to do some very hard questions. So, yeah. Okay, so we did the conical pendulum, but we didn't do one thing. So I'll have to do the conical pendulum from the beginning, so don't worry. Okay, so as I said, that conical pendulum, it looks something like a normal pendulum, but it doesn't act that way. It rotates like this. And this is the example of the horizontal circular motion. And this was our normal line. Okay, so can anyone remind me what was providing the centripetal force? Come on, guys, let's see how well you remember yesterday's class. So you know that this is the centripetal force. So guys, come on, what is providing the centripetal force? Yesterday I had a few answers and unfortunately, bros, did you forget it? It's the sign, the tension sign. It's not the tension. I mean, it is the tension, but if we want to be exact, if we want to be precise, it's going to be T. Okay, now tell me, is it T sine theta or is it T cos theta? It's sine. Don't forget yesterday's lecture. Okay, so it's T sine theta. And I also said that this is T cos theta. And I also said that this is my weight. And I said that W, now this is where we involve some derivation. So W is equal to T cos theta, right? And I also know that FC is being provided by T sine theta. Now, if you don't like math, I am sorry, but we're gonna do some derivation. So yeah. Now, the first step is I wanna convert equation, okay, let's say this is equation 1 and this is equation 2. So right now I am talking about equation 2. So I am going to convert my equation 2 in this form. Okay, can anyone remind me what was the formula for the centripetal force? What was the formula for centripetal force? Come on, guys. I want the velocity one. I need the one which involves the velocity. Come on, guys. What is the formula for centripetal force? Come on, it's such an easy question. Why is it taking so long? Okay, mv squared over r. That's the right answer. Now, our equation 2 is ready. Now, we are gonna talk about equation 1. So this is equation 2. I mean, I don't need to write it again. Okay, now we know that W has a formula as well. Can anyone please remind me? What is the formula of weight? Exactly, mass into g, so mg. Now, this is where I am going to involve some math. Now, what I'm going to do is I am going to take equation 1 and I'm going to take equation 2. So I'm going to divide equation 2 by equation 1. In case you're wondering why am I doing this, because I want to get a special something and you guys should know what that special something is going to be. Okay, so it's going to be mv squared over r divided by mg. I mean, I'm going to write it like this because that's just the right way. Okay, let's write it like this. mg is going to come here. Okay, so now tell me, what is sine divided by cos? Okay, how do I solve this? Come on, guys, basic math. I mean, even the ones who do biology in A-levels, they should know what this is. Okay, exactly, it's tan, and we know that. Hey. Okay, so I just muted. Okay, all right, so we're gonna cut the tension above and below. And I know that sine over cos, it gives me tan. So let me kind of make it smaller so I can move it up. Okay. Now, I know that this is going to be tan. So let me use a black color. So this is going to be tan theta, right? Now, it's a question for you guys. Let's see who is good at math. How do I solve this? What do I do here? What do you think, guys? It's not such a hard question. It can confuse students. That's why I'm asking, because it can get confusing. Okay, so Varun says move the mg up, and Ima says mv squared over r multiplied by mg. Okay, now let's observe. Now I know that mv squared over r, can I say that this is basically multiplied by 1 over mg, right? I mean, isn't it the same thing? If I'm dividing mv squared over r by mg and I'm just multiplying it by 1 over mg, so I think that it's going to be tan theta is equal to mv squared over r or mg. And we know that mm is going to get canceled out, and I mean, we're going to get a new formula. I mean, you're not supposed to remember this formula, but you are supposed to know that in the paper they're going to ask you how to derive these things. So yeah, it's going to give you v square over rg. So you're not supposed to remember this formula. But what you are supposed to know is that in the paper, they can ask you this question. And in fact, today we might as well do a question that may involve it. I don't promise. Okay, now everyone, please note it down. And I mean, you noted this down yesterday, so just add this derivation, and we're gonna move on to the next part. And when you're done, tell me, so I can, erase this stuff. Hey, Rayan, you can actually check the meeting ID and the password of the meeting in the group. I think Ima sent the meeting ID and the password in the group. Or I don't know who sent, but someone sent it. So you can just open the WhatsApp. Yeah, so she did. So you can just open the WhatsApp and you can check it there. Okay, that's amazing. Now, you guys might get a little deja vu or something. I mean, we did it recently, but let's do it again. Okay, now. Okay, I don't know how I have the static sound. Hey, wasn't the static sound gone? What? Okay, that's weird. Okay, thanks for pointing this out. Let me try to fix it. Okay, that's amazing. Let me just check if the voice cancellation is on. Okay, then that's weird. So the voice cancellation, I mean, not the voice cancellation, so the noise cancellation. If it was the voice cancellation, you wouldn't hear me in the first place. Okay. So I am sorry, guys, if anyone hears a static sound, it must be, I don't have a pop filter, bro. I just have the noise cancellation so you don't hear the background noise. Anyway, so let's continue. So the other day, I was telling you that we have roads like this, and I mean, everyone likes to drive fast. There's a lot of people who drive fast. I mean, there's literally Formula One, I think that's what it's called. So there's a lot of cars who drive really fast at very high speeds. So how in the world do they avoid this thing? So let's say I am driving like this, and we know that this is circular motion too, right? And I also said that this arrow, it represents my centripetal force, and it is towards the center. So how do people avoid it? I mean, it's unavoidable because the higher, the faster you go, the more you're gonna skid. So if you wanna make the car over here, this is gonna be our skid force. This is gonna be the skid force. And because of this skid force, we know that every action has equal and opposite reaction. So as I get this skid force in the opposite direction, I'm gonna get more friction and thus more centripetal force. And this is gonna allow me to remain in this motion. So that's what we did the other day. Now, what is the solution? Okay, so what is skid force? Okay, Amna. So listen. So Varun is right. Yeah, Varun just literally predicted the future. Okay, so Amna, skid force is, so imagine I have a car and it is supposed to go right here. Like it is supposed to travel in this line. But since there's not enough friction, there is not enough friction on the road, the car kind of slips, it kind of slips. Like when people drift, when they kind of want to act cool, when they drift and the car kind of slips on the road, kind of skids on the road. Now that skidding is the skid force. And thanks to this skid force, I gain more friction and thus more centripetal force. But that's not important because we are doing the banked road concept now. Okay, so Rayan asked a question, does GPE and K include this chapter? No, bro, that's the chapter for, that's in the gravitation chapter. So let me erase this because this was just a recalling thingy. Okay, so the solution to this is banked roads. Now our engineers or physicians, I think engineers most likely, they designed banked roads. Now, how do banked roads help us in dealing with friction? Now, let's make a really cool car. I mean, I don't promise that it's going to be a cool car, but let's try to make one. Okay, so we are going to make the tires like this. I mean, it already looks bad, so no problem. Okay, so these are our tires. Tires look something like this. And let's make a blue car. So this is going to be a bluish car. And okay, this is our car. I mean, it's not complete yet. So these are our lights. Let's say it's night. Okay, it looks terrible. Okay, so now we have the windshield. I guess that's what it's called. And the rooftop. I mean, the roof or something. And that's our car. Okay, it looks bad. Okay, so 1, 2. Let's say that's a number. Okay, so this is our car. And now, because it's inclined, you know, we know that there's weight acting towards the, you know, the bottom. So this is weight. This W, this is weight, and it's acting downwards. Now, if I make a normal line over here, I know that this is angle theta, right? And I know that angle theta, whenever we have an angle, and if this is our normal line, so can I say this is an inclined vector? So will I have components? Will I have two components? I mean, I am supposed to have two components, right? So can anyone tell me what are going to be my components? Yeah, cos and sine. So let's make an arrow for one of our components. And I'm going to ask you, which one is it? Is this the sine component or is this the cos component? Is this component the W sine theta or W cos theta? Come on, guys. AS. Yeah, it's sine. Good job. Okay. Now I'm going to move this component later to the to that part. Now, first of all, before I do this, let me do one thing. Now, before, in our old scenario, our car was like this. I mean, I don't want to make the car again, so let's just do a faster version. So before, we had our car over here, and this is the front view, by the way. I know it looks bad. Okay, so this is the front view, and let's say this is this was the direction of our friction, right? And this friction provided the centripetal force, and let's say this is our, the center of the circle, right? So friction was exactly horizontal in the previous scenario, but now, because my car is inclined, my friction is gonna be in this direction, right? Because the friction with the road is over here, right? This is the part where we have friction. So this, let's make a different color because we're gonna get confused with weight. Okay, let's use a red color. So this is, what did I do now? Okay, so this is the direction of friction and it's acting towards the center because now our circular motion is, here. Okay, let's read your comments. When linear angle is sine, when away is cos. Okay, so cos is gonna be, I mean, you should be able to know, but I'm gonna tell you still. So cos is gonna be over here. So this is my W cos theta. So this is gonna be W cos theta. So now listen, how do banked roads help us? Whenever it's horizontal to the normal. It depends where the angle is. So we can't really confirm that. Okay, now listen. In our previous scenario, now listen very carefully because this is where you're gonna understand how in the world do banked roads help us in dealing with skidding. Now, this was our friction, right? And you know that this friction was not enough to provide us the centripetal force. So this friction right here, it was not enough to provide the centripetal force because we needed greater amount of centripetal force. we needed a lot of this because the car is going fast and we need a very high amount of centripetal force. Now, this friction is not enough to give us this. So if this was 20 newtons, friction would give us just a half, and we need more than that. Now, look at this. If I move this arrow over here, wait a minute, what did I just do? Didn't I just add another force which is acting towards the center? So now my centripetal force is going to be friction plus W sine theta, and not just friction like in the old scenario. Okay, so Key says why W is not denoted by the pink line. Bro, listen, tell me one thing. Is my gravity down here or is my gravity over here? I mean, if this is my road, right? This is my road. Is the planet's bottom over here? Is this my Earth? Or is this my Earth? Tell me this, Key. I don't know what your real name is, but whatever it is, tell me this thing. Is my Earth here or is my Earth over here? Obviously down, right? So if Earth is over here, how in the world do I have gravity coming from this side? Now, obviously, since my Earth is over here, my weight is going to be down here. So this pink arrow, this is just a component of this W. In reality, my W is down here. So I hope that answers your question. Okay, so I was saying that now our centripetal force is not just friction like in the old scenario. Now our centripetal force is friction plus W sine theta. And this gives us enough centripetal force to remain in this circular motion. Obviously, that's enough centripetal force. So now this is going to give us enough centripetal force, and that's how we avoid skidding. So prevents, I think prevents is the better word. So prevents skidding. Obviously, because we know a lot of racing tracks, let me kind of show you. So a lot of racing tracks are like this, no? So meaning there's going to be a lot of turns, and we know that cars, they're not traveling at 20 kilometers per hour. They're traveling at hundreds or even, I don't know, I don't watch it, so I don't know the exact speed, but it's really high speed. So obviously they are going to have to do something to avoid skidding. So they have banked roads. Okay, is this clear, everyone? Does anyone have any kind of confusion in this concept? Because it's kind of important. Come on, I just have one answer right now. Is everyone sleeping? Okay, it's clear. That's great. All right, that's amazing. Now, we're going to do a pretty fun thing. So note it down, and once you're done, tell me, and we're going to do a little fun thing. And after that, we're going to do some questions. Okay, that's great. All right, I'm erasing this. Okay, so now let's get a bit serious because this question, it's a bit confusing. So I'm going to use a black color. So I tried this thing the other day and it was really cool. I think I should have made the turntable like this because, I mean, it looks more like a turntable. Just a second. Key has the question. W sine Q. No, bro. W sine Q is not the skidding force. W cos theta, it's just one of the components of weight. It's just one of the components. It's just a component. And this time, we don't have any skidding force. Skidding force is only when we have a simple road. Do you understand? Now, when I have a banked road, there's no skidding at all. I mean, at least at our level. Do you understand, Key? I don't know what your real name is. So yeah, I'll just call you Key. So yeah, I hope it's clear. Okay, amazing. Now let's move back. Okay, so the other day I tried a really cool thing, and I think making a turntable like this is kind of cooler. So it's a fun question. Now let's say I have a piece of mud, right? I have a piece of mud over here, and yeah, this is my piece of mud. And I have the center of the circle. So this is the center of my circle. And this is, in fact, let me change it a bit. So this is the direction of my motion. Let me erase the mud. Okay, now, pay attention, everyone. Now my mud, it's actually a uniform there. Why mud? I mean, bro, that's the question. The question says it, so it's not in my control. So let's say we have mud all over the turntable. Hey, just a little question. Does anyone hear like an annoying sound in the background? Because there is a sound. Do you guys hear it? Like, you know, a hammer. Okay, that's great. Because there's some work going on here. Okay, no problem. So this is the uniform layer of mud. Now let's label it. So this is, oh, let's use a different color. Okay. So I have a uniform layer of mud. So uniform layer of mud. Now, my question is, from where? I think I'll phrase it first. So when I'm spinning it, from which point is mud gonna fly off first and why? Let me write it down. So from where is the mud gonna fly off first? So Varun says the mud that is farthest away from the center, and give me a genuine reason, you know, why. Oh, Rayan, listen, there's no up and down. This is horizontal. This is horizontal. I made it, you know, vertical just for our understanding. In reality, this is horizontal. So there's no down and up. Okay, so what do you guys think? Okay, so Varun seems to have a really nice answer. Does anyone else have an answer? Come on, guys, don't worry. Even if you answer incorrectly, it's gonna give you more confidence when you do the actual question. So Aisha says the one, you know, basically we have two answers right now, and two of them are saying, you know, the edge. Okay, so your answer is edge, and I have some good news, and that's the correct answer. Now, you guys might be wondering, isn't that obvious? Come on. I mean, if we literally, you know, start spinning it, it's kind of obvious. Our brains can comprehend it, that mud on the edge, it flies off first. But in the world of physics, we have to explain everything using the actual terms. Now, the other day, I said that at different points, we have different centripetal force. So at the edge, since the radius is the maximum, we are gonna have the greatest centripetal force. So this point, you know, the edge point, it has the greatest centripetal force. And as it has the greatest centripetal force, it also has the greatest velocity. Now I'm gonna write some statements. So from the edges, okay, from the edges, mud flies, okay, I don't know if that's the right spelling, flies off first. Okay, so if my spelling is wrong, do correct me, because LOL, I forgot. So from the edges, mud flies off first as the speed is highest and FC is highest. Now, I have something amazing to ask you. Tell me one thing. What is providing the centripetal force here? You know, I have a turntable, and on my turntable, I have mud. What is providing my centripetal force? Come on, guys. What do you think? Be amazing. Okay, so we have one answer, but I'm gonna wait for everyone's answer. Come on, guys, what do you think? Okay, we are getting there. Okay, come on. Anyone else? Come on. Even if you answer incorrectly, I just want to see, what are you thinking? Okay, so all of you have the right answers, but Lagina, I would rephrase your answer to friction between the mud and the turntable. So in this scenario, let me move this just a second. Let me select this and let me move this. Okay, so friction is providing the centripetal force. So friction provides FC. Now I'm going to tell one statement and you guys might clear up your concepts from yesterday. So yesterday I was teaching you this concept that in all kinds of circular motion, when you are spinning, you are more likely to move out. And I wrote one statement. Now I'm going to write this statement again. Particles move out to gain friction. Don't you think that I can gain friction when, the more contact I make with a surface? So if my mud is moving to the right, isn't it actually gaining friction? So that's why, that's the reason why the particles move out. That's the reason why they fly off. That's the reason why they fall off the turntable when the turntable starts spinning. Because the particles move out to gain friction. Yeah, you could say that. You could say that. So, is everyone clear about this? I'm going to give one last example after this, and then we're going to do a fun question sheet. But that's going to be in our next Zoom meeting because I'm going to end this Zoom meeting after the example. So, note it down and tell me once you're done. Okay, Aima, tell me one thing. Particles want to gain friction, right? Now, is it possible that my particles will move to the left? Okay, no problem. I'll explain it to you guys. I have a question for you guys. If my mud, if my mud wants to gain more friction, right? Forget about everything. So this was a separate question. This question was separate. It was the question where the mud is going to fly off first. But this friction thingy, it applies to all mud. When I start spinning the turntable, all of the mud tends to move out. It tends to fall off the turntable because it wants to gain more friction. Now, the question of Ima was, I'm going to interpret it in this way. She asked, how in the world do I have more contact in the edge? Ima, are you saying that why doesn't mud go to the left because there's a lot more surface area? Are you saying this? Or what was your question? Can you please elaborate your question so I can give you a quality answer? Okay, now listen. Physically, it's impossible for my particles to move to the left, right? That's just impossible because particles move out. Now, if your question was about the edge, the question with the edge was completely different. The question with the edge, as I said, it was from where is the mud gonna fly off first? Now that question was different. And this part, this thing is different. This thing is about all of the mud. And this thing is about the edges. Now we know that when I start spinning it, all of the mud, it wants to move away. It wants to fall off the turntable, right? So obviously this mud right here and this mud right here, both of them want to go away. They want to fall off the turntable. So let's say this green line represents this. Now, isn't it obvious that the one on the edge is going to fly off first, and it has more centripetal force, and it has greater velocity? Meanwhile, this has lesser centripetal force, and it has lesser velocity. So obviously, it's going to take way longer for it to fall from here. And we also know that this mud, it has the opportunity to gain all that centripetal force. So it's going to stay on this for longer. But eventually, if I keep spinning this, all of my mud, the one at the center, the one in the middle, the one at the edge, all of it is going to fall off the turntable. So a simple one-line answer is just look at it this way as two different things. Mud at the edge flies off because it has greater centripetal force and it has greater velocity. if you write in the paper that because it's on the edge and it's common sense, they're going to give you 0 marks. You have to write actual reasoning. And the actual reasoning is because the speed is highest, the centripetal force is highest. Now, what provides the centripetal force? Friction. Particles move out to gain friction. That's why the particles are falling off the turntable. Is it clear, Aima? If it's not clear, I might be able to explain this in the next example. Okay, so I assume everyone has written this. I'll just be waiting Aima's. Okay, so that's your question. Okay. Oh, Aima, did you take the class the day before yesterday? Yeah, I think you missed it. No problem. I'm going to explain. Oh, 1 second. So your question is now that how is the speed greatest at the edge? Okay. Okay, so let me just confirm one thing. Is that your final question? Why is the speed greatest at the edge? Aima, can you confirm one thing? Is that your final question? Okay. So I have 2 minutes. The meeting is going to end on its own. So don't worry if the meeting suddenly ends. Let's see how much I can explain here. So I'm going to make the turntable. This is my turntable, and it's spinning, right? This is my center of the circle, and this is my point A. Let's say this is an object on the turntable, and the turntable is spinning like this. I have 1 minute left, LOL. The meeting is going to end soon. Okay, this is point B. Now, we know that FC is what? FC is mr omega squared, right? And I also know that omega is constant. So FC is directly proportional to R. So since the radius of point B is greater, that should settle. FC has the greatest centripetal force. All right? Now, moving on to the velocity. I know that velocity is R omega, isn't it, right? No, tell me one thing. Isn't omega constant? So can I say that velocity and radius are directly proportional? So just like centripetal force, my velocity is also the greatest, right? Do you understand now? So this is basic formula derivation. So don't confuse yourself with, okay, isn't this one turntable? Oh, so shouldn't A and B have same velocity? Forget it. What does the formula tell you? Just keep that in your mind. So in Pakistan, there's a community. It's called, the Pathan community, right? So he went to their community and he tried, I think they were his friends or something. But, okay, if you're watching this right now, sir, I'm sorry. I'm using your life examples in my class. LOL. I literally can be copyrighted for this because I've used the examples twice now. So there's this, hey, what is it called? So in Urdu, it's jhula. LOL, I don't know what jhula is. Hey, can anyone tell me what is jhula in English? And what is it? Can anyone tell me? So I forgot. LOL. So basically, yeah, a ride. Yeah, you could say that. So basically, I mean, it's not this, but it's what I imagined. So at least in my childhood, we used to play with these things. So let's kind of make it, it's a really bad drawing, but doesn't matter. So he basically was playing with them and they started, I don't know if this is the exact ride, but let's say this is it. So they were spinning really, really, fast, so fast that there was a moment when he was literally holding his hands like this and he was about to fly off. Like, literally, he was about to lose his life or something. And that's when he finally understood what in the world centripetal force is. I mean, isn't it the best example? Why is it that when you spin this, it literally feels like you're gonna fall, I don't know, you're gonna go to Mars or something, This is Earth and that is Mars. That's how far it feels you're gonna fall, you're gonna fly. Like you're gonna turn to Superman or something, I don't know. So this is meeting ID and password is not valid? Bro, I don't know. Elon Musk. So basically, when you spin it really fast, and you guys should notice because all of us have been in this ride. When we're spinning it slow, right? When we're spinning it slow, it doesn't really feel like we're gonna fly off like this. It just feels like we're not gonna be so well, you know, maybe we're gonna get a bad stomach or something. I mean, I don't know what it's called, but maybe you are gonna do something, right? You know, and you're holding your hands like this and it's a bad day. But when you start spinning really, 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 really fast, you can fly off and maybe you can even lose your life. So it depends how fast you spin. Now, you guys should be getting deja vu because I taught you that, you know, objects or bodies, they tend to move out to gain the centripetal force. So the more I'm spinning this, the faster I'm spinning this, the more you know, get to this situation. You become this man right here. So why is it? Tell me one thing. What is okay? So why don't you didn't miss anything? Yeah, you just I am telling this, so don't worry. And it's being recorded, so yeah. Anyways, guys, so what do you think is providing the centripetal force over here? So we have a few gentlemen here. Let's make another one. So these people are holding, let's say this is the crazy man and he's spinning it really, really fast so that you guys become this man. So let's make an evil expression or something. So this is our evil man. He's evil and he is spinning it really fast. So what is providing the centripetal force? What do you guys think? Yeah, the friction. So basically, the friction of our hand, basically our contact force with this thing. Now, this should also answer your question. Yesterday, one of the students, I think it was Varun or something, he said that for a washing machine, why doesn't the motor provide the centripetal force? I answered that already, but it's another answer. So if you're spinning this thing, you should think, okay, so this is providing the centripetal force. But in reality, your hands are being, are in contact with this wheel and you are spinning, you're applying the force and it becomes faster and you gain that centripetal force. And that's why you become this fan when it becomes really, really fast. It's because your body wants to move out so that somehow you gain more centripetal force. So just to recall, in circular motion, bodies, just a recalling thing, bodies or objects tend to move out to gain the centripetal force. And that's why this is happening over here. I mean, that's why this is happening over here. So I hope this clears up the way centripetal force works. You're not supposed to know the physics behind how this ride works, but yeah, for someone, for some people, for my teacher, he almost lost his life and only then he understood what centripetal force is. So I hope you don't have to experience this to actually know what centripetal force is. So I don't think you need to make this unless you are very passionate. So I'm saving the picture and I am basically, you guys will see this for a while until I open up some questions. So just give me a few minutes. I mean, I hope it's going to be 30 seconds, but if it's long, I apologize. Give me a little while. I'm going to search for, I have the questions open. I'm going to show you the questions. I'm typing right now, so don't start counting now. Hey, so Ima had a question. Hey, I'm sorry, Ima, I just saw. Shouldn't the person be pulled away then on that ride to gain enough force on that jula? Yeah, exactly. Exactly. The person should be pulled away. That's why the person is being pulled away. Okay, anyway, I'm turning off the mic and I am starting, I'm searching. So I am in Safari. Okay, so we have some questions here. They might be a bit hard. By the way, a lot of people are wondering what our next chapter is going to be. It's going to be simple harmonic motion. I know you guys expected it to be gravitation, but don't worry, it's going to be simple harmonic motion. Okay, I have the questions. So let me share the screen. So welcome to Safari. Exactly. We are using a Mac, so it's a Safari. I mean, it's Safari, it's not Google. Okay. So can you guys see this? Hey, guys, are you alive? Can you guys see this? Come on. Are you guys able to see the screen? Okay, that's great. Oh, I didn't get the notifications for your message. Okay, amazing. Now let me use the whiteboard. Let me annotate. So I'm giving you a few, that's amazing. I'm giving you a little while. What is the answer to question 1A? Come on, we literally did it that day. You don't look at the notes, just tell me in your own words. I mean, not in your own words. Bro, I think it's the radian. It's not the angular displacement, man. Varun, that's the definition for angular displacement. I'm asking you. Exactly, so these are the right answers. So the answer is simple. Angle, it's in the notes. So angle subtended by an arc at the center of the circle equal in length to the radius. So let's write it fast. So don't forget this. S is equal to R and theta, S is equal to R theta and theta is equal to S over R. Yeah. So that's pretty much it. That's an easy question. Now, this is going to be a bit, it might be a bit tricky because it's a bit different than the actual definition. So a small mass is attached to a string. The mass is rotating about a fixed point P at a constant speed, as shown in figure 1.1. Explain what is meant by the angular speed about point P of the mass. What do you think is the answer, guys? Explain what is meant by the angular speed. Come on, you guys don't know? Do you guys forget? Guys, are you thinking? Yeah, the definition. Bro, it's 2 marks. Yeah, you know, but you don't remember, so you don't know. So, just kidding. Okay, so if anyone knows, look, she wrote. So yeah, no, but one thing. So the answer is, I'm gonna give you a little bit time. What do you guys think is the right answer? Come on, I want to see you guys answer the question. The right answer. You can, for your understanding, kind of remember change of angle subtended by an arc, the speed of an object moving in circular motion, speed it takes to cover the angle in time. That's somewhat it, but that's still not it. That's still not it. Rate of change of angular displacement done, rate of change of angular displacement, how fast an object. Okay, so there's only one thing missing here, and I'm gonna tell you that. So look, tell me one thing. We know that angular speed, angular speed is basically, what's the formula for angular speed? Come on, does anyone know? The general formula. Guys, what is the formula for angular speed? Yeah, theta by t. Yeah, so basically, we are doing angular displacement per unit time. That should be the answer. But in this question, they need an answer relative to the point P. Basically this thing, right? So the correct answer to this question is angle swept by the string per unit time. Per unit time. You can also say rate of change of angular displacement, and you have to mention that angle is swept by the string. So the ones who answered rate of change of angular displacement, that's the correct answer, but you're going to get 1 mark. You're only going to get 1 mark. So the second mark is for angle is swept by the string. So you have 2 possibilities. The first one is write the definition and then mention that angle is swept by the string. And the second the second option is just write this: angle swept by the string per unit time, because you are basically moving, right? You're changing, you're doing angular displacement. So you're swept, you're traveling in terms of angle per unit time. Is this clear? Is anyone confused about it? Okay, that's great. So if you want to note down a definition, I mean, you don't need to note down, just take a screenshot because it's a past paper. So I'm clearing it up, and let's see the next question. Displacement, Sabina, displacement. Distance is not a vector. Yeah, it can ask. It can ask angular velocity as well. If it just asks, okay, that's a very good question. So they mentioned angular speed, but I also said that we can use both. It's angular speed and angular velocity. I understand your point, but whenever we write the definition, we say angular displacement. I might be wrong since I'm a student myself, but I have never seen an answer that says angular distance. I have never seen it. So that's why we're not going to write it, because that can penalize us in the paper. So we shouldn't use too much time on simple definitions because the real questions are coming now. Okay, let's look at the question. The question, you guys can read the question. Come on, let's read the question. So we have a horizontal flat plate that is free to rotate. It looks something like a turntable, but it's not. About a vertical axis through the center as shown in figure 1.2. And now they have placed a mass, a small mass m on the plate, a distance d from the axis of rotation. The speed of rotation of the plate is gradually increased. Now, they are increasing the speed from 0 until the mass is seen to slide off the plate. So they're basically increasing the speed, and they want to see it at the very edge. Now they say that maximum frictional force F between the plate and the mass is given by the expression. So this is an expression that gives us maximum frictional force. Okay, so W is the weight of the mass M and distance D is 35. Now they're asking us, determine the maximum number of revolutions of the plate per minute for the mass M to remain on the plate. Okay, so it's a 5-mark question. I'm giving you guys a little amount of time. Let's see who can answer the question. If you need me to scroll up, just tell me, I'll scroll up for you. But for now, I am gonna stay in this position. Okay, let's see who answers correctly. Oh, nice. So Varun has an answer. Okay, so Varun, I'm going to take your answer. That's 1543. Okay, we have, I just want to see your answers first. I am not going to tell you the right answer because I want to teach you how to attempt a paper. Because, I mean, this is not a passive procession, but it's still important to know how to solve a paper. Come on. Okay, I'll just wait because little time has passed, so I don't expect everyone to have solved it by now. But I do want to have an answer from everyone. But I have to say, I'm amazed by your speeds because it's a 5-mark question. So it usually takes, 3 minutes, 4 minutes, something like that. So it's impressive that you guys have the answers already. Okay, we have another 43. So what about the rest? Have you guys solved yet? No problem, man. I'm not raising my expectations, but don't underestimate yourself as well, man. Because you guys might be right, you guys might not be right. Okay, so come on, there's 13 students in this class. Has anyone else solved yet? But it's a little lengthy, like, it's a long question. Okay, so I'm gonna give you guys another 1 minute. Yeah, I'm gonna give you guys another minute because, yeah. I'm gonna give you one last minute and let's see how many of you answer. But I need an answer from a lot of people. Hey, Rayan, do you have a question? You just raised your hand. Okay, guys, so 1 minute is up. Come on. Have you guys solved the question? And I need an answer from everyone. Did you attempt the question? Because if you were literally just sitting idle, that's not impressive. Come on, guys. I need a reply from everyone. Did you solve the question? I know, guys, you guys are good, but I want to know about the rest because we have 13 students and I only have 3 to 4 answers. Come on. Are you guys alive? Hey. So, did you get the right answer? Okay, we have an answer from Lagina. Come on, what about the rest? Just type your answers, even if it's wrong, because that's how you get the confidence to solve the questions. Yeah, you don't want to mess up your Cambridge International exam, but you can mess up these questions. Yeah, Varun, ask your question. What question do you have? Okay, so what's your answer? Okay, so Varun says angle swept is n2 pi. What is that, bro? Angle swept is n2 pi? About this, in this question or the question above? Okay, let's see. All right, let's just solve the question. Okay, first, now pay attention. I'm gonna answer your question. Hopefully, it's gonna be answered as I'm explaining the question. Now, pay attention, everyone. This is friction, right? Doesn't this formula remind you of something? The ones who do M1 math, F is equal to mu R, right? Doesn't it kind of remind you of this formula? Kind of similar, right? So this is an equation from M1 math. So this is just, a little deja vu, right? But it's just to, give you the deja vu. It doesn't really matter in this question. Okay, so we have recalled that this equation is similar to A1. No problem. You're just supposed to know that basically in math, there's this formula for friction, and the formula is mu r. And mu is a constant, and r is the normal reaction. But you're not supposed to know it, so don't worry. Unless it's in the AS physics, because I don't know. Because I literally forgot the whole AS physics, because, yeah, that's kind of embarrassing, but yeah. So, now, whenever you're doing this question, tell me one thing. Is my what is providing my centripetal force in this question? Let's look at the question. What is providing my centripetal force? What do you guys think? I have an object, exactly. Eliza has the answer, friction. So look at the marks. They're giving us a lot of marks. Don't you think this is kind of cheesy? Well, there's a reason for that, because whenever you're solving these questions and you know that something is providing the centripetal force and there's a lot of marks here, write this statement. Centripetal force is provided by friction or frictional force, okay? So now we can say, can I say that friction is equal to Fc? Now this is where we apply the concepts we did. This is why I'm doing the questions, because I taught you, okay, so centripetal force is a resultant force, but when we do math, right, when we do these calculations, you gotta equate them. So friction is equal to the centripetal force. Now, I know that friction is 0.72, right? 0.72 W. And can anyone please remind me the formula for Fc? Which formula are we gonna use here? What do you think? Exactly, mr omega squared. So mr omega squared is the formula that we're gonna use. Now, you also know that W is mg, right? So can I say, let's first write this. Now, some of you might be thinking, okay, I don't have the mass. What do I do? Well, don't worry, because we can cancel it out. So this W, it's mg, right? And you know, whenever we have something that's on both sides, grab, you don't have multicolored option in the paper, just grab your pen and, just cut it off. You don't need it. You don't need it. Now, we're going to find omega. This is our first step. We want to find omega. Then we're going to find, the revolution or whatever. Okay, so now I know that G is 9.81, right? So 0.72 multiplied by 9.81 divided by R, right? The radius. Now, you know that distance D is 35 centimeters. But first, we want to make sure that this distance is actually the radius and not the diameter. Okay, this is the radius. And you guys should also know that whenever we do calculations in A-level physics, A2 physics, mind it, we use meters. So distance is always in meters. Never forget it. Not just distance, displacement, radius, all kinds of distance. It's in meters. So 35 multiplied by 10 raised to the power minus 2. Exactly, because we're grown-ups, right? We don't need to do 35 divided by 100 because we know prefixes, and you guys studied prefixes with Fazil, if I'm right. Okay, so now I know that omega square is coming here, right? So omega is gonna be the under root of this thing. So I don't have the calculator. Can anyone please calculate this? Yeah, I don't have the calculator. Can anyone please calculate this and tell me the answer? What is omega? And please don't round off too much, because that might not be so cool. Okay, 4.49. So omega is 4.49. I hope this is the right omega. Okay, so I'm gonna trust you. Okay, so this was what I said, Aisha. So whenever you're doing calculations, do not round off too much. If you have 4.49, if you have 4.85 or something, just use 4.4, the full form. But since I have the answer of 4.49, I'm going to write it as this. Now, what do we need? We need to find the maximum number of revolutions, right? And I also know that number of revolutions per minute, right? Just a second. Okay, so these number of revolutions per minute, this is the frequency, right? The frequency, isn't it? So if my frequency is per minute, that means when I find my frequency, that's not the end. Because we know that the unit of frequency is hertz, and hertz is revolution per second. So that's for later. Now, I know that omega has two formulas. And didn't I tell you that day that you have to know which formula to use when? So for those who don't know 2 pi f, they are going to do 2 pi over t, and then they're going to do, okay, so now I have the time period, now I'm going to divide it by, the reciprocal, and then I'm going to get the frequency. You don't need to do that. Just do 2 pi f, because this is a formula. So frequency is going to be equal to omega over 2 pi, and it's going to be 4.49 divided by 2 pi. So what is the answer over here? Can anyone tell me, please? Come on, guys. What is the answer? 4.49 divided by 2 pi. Oh, Legina, listen, I am pretty sure that that's not the full answer. I need the answer in at least like 3 decimal places. Come on. You guys are rounding up too much. Whenever you're doing calculations, do not round up too much. Okay. Hey, Varun, bro, that's a very different answer. 7.0. It's 0.7146. Yeah. 0.7146. Now, that's not the end. Now, some people might say, okay, I have the frequency. This is my answer. Incorrect, because this is revolutions per second. This is hertz. And we want to, no problem, bro. And we want to find out the answer in minutes. So let's look at this. Let's do some basic math. So I know that in 1 minute, I have 60 seconds, right? And if in 1 second, I am getting these revolutions and I want to find the revolutions per minute, I'll just multiply this by 60. And my answer should be around, come on, guys, what is my answer? So, yeah, 42 point, are you sure? Yeah, 42.87, that's the answer. But that's not the final answer. Now, please, everyone, I need your attention. This is something very important. Whenever you're solving questions in A-level physics, A-level examiners are kind of cruel, because if your number of significant figures in the answer are wrong, you're going to get penalized. So if I go ahead and write 42.87, you are going to get penalized. I know that's cruel, but that's just how A-level physics works. That's how they differentiate between the A-star and the distinction students as well. Now, look at the question. What is, how many significant figures is this? I have been given only one number. How many SF is this? Hey guys, so yeah, that's 2, right? So this means that my answer, now it's a rule, remember this. I'm sorry. So preferably just answer the same, in the same significant figures as this, but you can go +1. So if you go +1, that's all right. But we need a number, right? We need number of revolutions. So tell me one thing. If they're asking us for a number, it's either going to be, it's going to be a number, right? So I'm going to round it off to 43 because it has to be a whole number. And we also know that our data, the question is in 2 significant figures. But don't make it a hard and fast rule. You can also go +1. So 2 significant figures or 2 + 1, which is 3. But in this question, specifically in this question, we need a whole number because we need number of revolutions. So I am going to round it off to 43. Now, if someone is wondering, okay, so why can I not round it off to 42? Well, because they're asking us for maximum number of revolutions. And if my answer is 42.87, obviously 43 is going to be the maximum number. 42 is not going to be the maximum number. It's a very small number because our range is, within our range. So that's why my answer is 43. Is everyone clear about this? And you can see how much working I had to do. And only after that, I'm going to get these 5 marks. That's great. Yeah, Varun, the unit would be per minute. But since they just asked us the number, the unit is not really required here. If it was, I would tell you. Okay, let's clear this up. Okay, save and clear. Okay, now Go through the next question. You're going to get a little deja vu because we literally just did it. Now, you guys know the reason, right? But I want to know how you guys answer it, the actual answer. It's 2 marks. Let's see who answers the right way. It needs 2 points. You guys need 2 points. So it has to be 2 points. So come on, what is the answer? What do you guys think? Okay. Okay. Varun has an answer, but what about the rest? Come on, guys. We have a lot of students here. Hey, this is so weird. We had like 15 students. LOL. Our students getting tired. Lol. Okay, that's great. Okay, so that's your answer. Now, you guys are right. Now, there's 2 possibilities. Either you're gonna say that, you know, the mud near the edge is gonna fly off. Okay, let's not go with fly off. We'll leave first. Oh, LOL. I literally said gonna. This is a paper. Okay. We have to be formal. We don't, we're not supposed to be casual with examiners. Okay, so the mud near the edge will fly off. Okay, why am I saying fly off again? Bro, it's supposed to be will leave. By the way, don't use fly off. That's just an informal way of saying. Okay, so we'll leave first because it has the greatest centripetal force. By the way, our meeting is about to end in 1 minute, so that's it gonna be for today. Okay, so mud near the edge will leave first because it has the greatest centripetal force. Now, this is only 1 mark because now you have to justify why is your centripetal force the greatest. So we're gonna write 1 more point here, and it's gonna be just a second. LOL, the students are joining now. I mean, they probably left due to internet connections. Okay, so damn, before the meeting ends, I have to write the answer. Okay, now you have to justify the centripetal force, and it's going to be due to greatest distance from the center, as FC is directly proportional to R. Now, listen, guys, you don't exactly have to write what I wrote because this is the answer in my wording. The marks are going to be for this: greatest centripetal force due to the greatest distance from the center as FC is proportional to R. This is crucial. This is crucial. This is the second mark, and this is the first mark. Okay, now I'm going to read your comments because I switched off the chat. Theta by T. So Legina, I'm not using theta by T because I have an easier way of, because I don't know how much angular displacement we have. So it's a general formula to use 2 pi F or 2 pi over T. Okay, so I hope you guys are clear. 40 minutes are up. I am surprised how our meeting hasn't ended yet. It's 40 minutes and 23 seconds. So have a nice weekend. We're going to send you some questions. So you guys are going to solve some questions in your weekend. Revise the notes. I'm going to do my best to upload the video as soon as possible. So I don't promise to upload it immediately after the class, but as soon as possible. So anyway, thank you guys. Make sure to practice the questions and bye-bye. Allah Hafiz. Allah Hafiz.